Hello, good evening to all of you. So, am I audible now?
Yes, sir. Yes.
Okay. So, today we'll discuss some of the previous class practical. So, previously, so my screen is visible.
Screen is not visible, sir.
Okay, okay, just a second. Now it is visible.
Yes, sir. Yes.
Okay. So, there are in this programming there are four bands of different satellite image. So, we have to uh, composite or layer stacking all these images to give a color image or a multispectral image. So all these bands are imported like raster L5, band 1, band 2, band 3. So this is the code, CP stack B1, B2, B3, B4. So just want to run this and just plot CP. So it is display in the right side. So this is the band 1, this is the band 2, this is the band 3, and this is the band 4. So all these bands have different spectral reflectance from 0 to 255. So it is its maximum value is 0 to 250, and for band 2 that is 0 to 150, then 0 to 250, then 0 to 250. So these are the four bands. So I want to merge all this, and after merging I have to show a colorful false color satellite image. So that for this I have to write the plot RGB, then CP is my object, that is the image, and then R, that is red, is equal to 4, green is equal to 3, and B is equal to blue is equal to 2. Then stays in linear. So just run it. So it gives colorful satellite image. So it is the image of the Odisha near the Similipal Biosphere Reserve in the border of the Odisha and West Bengal. So this is the one tile of the satellite image. So it has the there are four bands are there in this. So these are all integrated different. Then it is the band 2, then that is the band 3. So all these band have different characteristics. So all same image having different reflectance values due to the different wavelength. So in this band 3, some of the agricultural land reflect more in these areas. Then in band 4, so it is looking totally white areas, and it is highlighted the water bodies. Land and water bodies are very clearly demarcated. So it is a infrared band. So most of the time infrared is used for identification of land water boundary estimations. So in if you want, then in the red band it is not clearly distinguished, and it is in the blue band it is not clearly distinguished. Same area and different bands. So some of the forest area and some of the water bodies are look like same in the blue band. Then this is also a near infrared band. Uh, it is also clearly demarcated the water bodies, and it is also a near infrared band. So it is also demarcated the clearly water bodies. So these are the bands. So if we One, if you want to create a RGB of multispectral band, then we have to layer stack all these bands. For this, we have to go to the image analysis, then just select L B1, B2, B3, B4, B5, and B7. Then click on composite band. Then it gives the output result. This is our output result. There is the composite band. So we have to change our band according to our requirement. So this is our band. So go to the properties. Then we have to blue for so for blue it is band 2, for blue green it is band 3, and for red it is band 4. So if you change our band wavelength, then it looks like a different color. So it is not a false color. So for false color, you have to give blue band 2, that is band 2 is the green, then green band 3, that is red, and red, that is infrared band 4. Then it create the false color image. This is the false color image. The same thing is created with the programming R. So it's same. So red is 4, green is 3, blue is 2. Stretching is linear stretching. So likewise, all these operations are can be uh, we can do using R programming, and also in different softwares like GIS, ArcGIS, and QGIS, and other softwares also available. So it is a graphics based software, so we can easily convert it. But in the R or any Python software, Python programming, we have to write all these codes, but basics is same. Okay. So these red areas are the forest areas. So it's the high density
Sir,
forest
your
area.
screen is not visible.
That's why it looks like
No screen is
a red
visible.
color. So
Hello.
the spatial resolution of a Landsat 5 is 30 meters. So if we measure the each pixel, then its distance from one dimension to the is 30 meter. So it looks like 30 meter into 30 meter.
Hello. Hello. Can anyone tell me when this class started?
Around 6:36.
Thank you, Bhavya. But as per the schedule, it was spatial analysis and modeling, something like that, I think.
Okay, today our, our earlier class teacher was some medical emergency. That's why I was asked to take class by Satyananjan Giriji.
I see. Thank you. So
Okay.
what did he show? Actually, I joined few minutes late.
He's,
So he
he's,
showed in ArcGIS something. I was on actually walking towards my home. Can anyone
he's
just
doing,
summarize?
he's doing R programming. He's giving the class on R programming.
I think something was being shown in ArcMap.
Now he
Okay.
has joined. Screen he has
Okay.
to. Hmm.
Now the screen is visible.
Yes, sir.
Okay, so some technical issues are there.
Okay.
Okay, okay, then we will discuss the supervised and unsupervised image classification. Okay, so during our manual identification of feature using digitization of the image, so there is not the dependent on the pixel boundary. So our identification, suppose this is the forest area, so it is visible now, the forest area.
Yes, sir.
Okay, so when we zoom it, then our demarcation of the line is independent of the pixel. So this is the pixel, this is one of the pixels. So from this pixel, this boundary, it is crossed through the middle point of the pixel. So the demarcation of different forest area or other land use classification.
So, if I understand correctly, we were being taught creation of false composites using R programming, right? Changing the band and all.
Yes, yes.
Okay, then various supervised and unsupervised based image classification techniques are there in remote sensing. So we will discuss this. So these are the different spectral bands we have already discussed in previous classes. So this is the satellite image of different pixel informations like the reflectance values. So it is a single band image, so it look like only black and white and gray informations. And this is right side, this is the multi bands. So this has also different color and different reflectance values. So all these images has some matrix level informations for each pixels have different information based on the reflectance. So based on these values and these associate values or these neighboring near values, it creates some different identification of features. Okay, so this is the satellite image. Then it create different features based on the reflectance value of the raster image. Suppose this is the agricultural land, then it is a wetland, then it is a scrubland, then it is a scrub forest. So based on the information, suppose this is an idealized landscape having different uh, aggregate same nearly equal values of one features. Suppose this is creating a boundary having the nearly equal reflectance in values. So it create one boundary of different features, and then it created different boundary. So likewise, all different classes are created. So, but naturally, in the uh, real time work, so it is not identified like this. So various complexities are there because some of the reflectance value of some objects have equally same to the other object. So if they are near to each other, so it may be some error for identification in machine learning technology. But manually, it may be uh, very accurate. And after identification, some field work, so I identify of field level information, then the accuracy is very high in manually identification. But some issues are there, as suppose we have to digitize a district or a one state land use land cover classifications, so it takes time. But in machine learning, we have, if give the some sample data or any unsupervised classification, then it give the result within 10 to 15 minutes. So that's why we use the machine learning technology for identification of features for different purpose. But at the same times for accuracy assessment and identification of features for high level information, so we need some basic field data information so that it cannot be wrongly identified. So this is the introduction to image classification remote sensing, and it has the main. There are two main approaches of the identification of image classification, that is supervised image classification and unsupervised image classification. So like land use land cover classification based on supervised and unsupervised classification. So in this it improves the understanding of spatial pattern and landscape dynamics, and it involves some training data like some sample data. A lot of algorithms are used for identification of boundaries of different features. So how they are created a boundaries based on the pixel informations. Then different algorithm yield varying accuracy depending on the data quality. So if it is a high resolution data, then the accuracy is very high as compared to the low resolution data. Suppose we have the Lancet 5 data and we have the Sentinel 2 data. So the accuracy is more in the Sentinel 2 data because Sentinel 2 data is 10-meter spatial resolution and Lancet 5 is 30-meter spatial resolutions. So likewise, the resolution is one of the important factor for the identification of the features. Then the different bands involved in this. So reflectance values also give that one of the important resultant to this classification. So there are two type of classification, that is supervised and unsupervised. Then supervised classification is mainly of maximum likelihood classification, that is MLC. Then minimum distance classifier, then parallel pipe classifier, then support vector machine, that is SBM classifying technology, then random forest. So a lot of classification also there, but majorly these classifications are used in the remote sensing. These five classification in supervised classification, and in unsupervised classification, K means an ISO data, so basically used for unsupervised classification. So K ISO data means iterative self-organizing data analysis technique algorithms. So what is supervised and unsupervised? So in supervised classifications, we have to give some training data, so some sample data. So suppose in a district there are thousands of lakes and hundred of forest areas are there. So we have to calculate the all these with this supervised classification. So we have to give the sample of 5 6 forest pixel informations. So they collect, the machine collect all the information of these pixels. Then it calculate the average of these pixels, how these pixels are arranged in particular categories. In forest category, suppose forest categories, there is the reflectance value is 150 or 160, likewise arranged. Then it is observe this classification, observe these values. Then in the water bodies, it is look like dark features. So we just give the sample of 4 5 water bodies informations. Likewise, all these features, 4 5 samples we have collected and just give to the machine. Then based on our sample, our given to the system, it create a total land use land cover classification of the all district areas, so that it classify based on our sample data. So sometimes the choosing the sample data by the user also depends on how the accuracy is. If he or she has some error in the collecting the samples, then it gives the error to the final output to the land use land cover classes. This is the supervised. So it is the user supervised the classification technology by when used by the machine learning. But unsupervised is, so it is not uh, given any data to the data by the users. So when there is a data, suppose this is a satellite image, we just check that. So there is a water bodies and there is a forest areas and some agricultural land and some wetland is there, and it is a mangrove areas and some sea area water bodies is there. So and is and one sand area is there. So I just look into the satellite image and just observe that there are five or there are 7 or 8 classes are there in this uh, satellite image. So basically, a lot out of these other classes are also there, but major 7 or 8 classes are there. So we just go to the uh, tool and just give the information that there are 7 or 8 classes in this satellite image or in this location. Then based on the reflectance values and based on the arrangement of the pixels, it gives the land use land cover classification based on the 7 classes. So it may be sometimes accurate, sometimes giving some of the error, because it is depend on the user and based on the different reflectance value of the images. So sometimes the similarity of the reflectance value of different features gives the error. So some mismatch of the boundary is happening. So this is the supervised and unsupervised classification. Just I show you one of the classification after completing this. So this is the technique in this classification. Suppose these are the pixels information of different reflectance. So suppose the blue is the water body pixel and the green is the forest area
Hello?
pixels.
Sir,
So
your voice is not
sometimes
audible if you are.
some water
I
bodies
think
are also present in the forest areas, and some of the having some of the tree or any some greenery areas are there in the water bodies. So it also create a boundary based of the mass boundary informations. It may be some of the features are neglected or it is avoided, but major of the areas are calculated within this boundary. So this is the main theme of this classification. So how to demarcate two features, pixel based features based on the reflectance values of the pixels. So various methods are there. So these are the maximum, minimum, and parallel piped and SPM random forest. Then maximum likelihood classification. So it is most widely used supervised classification technique, and it is probability theory and assume that the statistics based on the probability theory,
sir,
and
your voice is not
it
audible.
requires training samples like some different area samples to be given to the machine. After that, it gives the resultant. So it is also based on the Bayes theorem, and it it requires more processing than minimum distance and parallel pipe classification, and it is sensitive to training sample quality. If training data is poor, then its resultant may be inaccurate. So it is based on the training data. So accuracy is depend on the training data. So most of the classification of water bodies and different land use land cover are included based on the maximum likelihood classification. This is the likelihood classification technique. So different coral algae and sands are segmented differently in 2D form is given shown in these areas. So this is the maximum likelihood classification. So how these features are demarcated and
Hello.
separated and based on the pixel values. So based on these, all these different features are classified. Then minimum distance classifier, it is also a supervised classification. It is a it is a simplest supervised classification technique, and it assign each pixel to the class whose mean spectral values centroid is closest to the pixels spectral value in feature space. So mostly, suppose there are three features are there: class A, class B, class C. So their mean is calculated, and how this is close to the boundary of each of the features. So this calculated, then it created a different boundary. So it is a Euclidean distance based calculation. Then parallel piped classification. So it classifies pixel based on decision boundaries defined in multi-dimension features. So some training samples are collected for each land cover type, that is water, vegetation, and soil. Then for each band, determine minimum and maximum value. Like minimum is suppose 10 or 15, and maximum is 240 or 230. So based on this minimum and maximum, it's the constructs a rectangular box parallel pipe for feature space, and if spectral values all inside a box, then assigned to that class, and if outside the box, then it is unclassified. So based on this, it can classify these features. Then support vector machine, that is one of the important machine learning classifier. Based on the statistic learning theory, unlike traditional classifier like maximum, like Lu and parallel pipe, SVM is non-parametric, like it does not assume any specific data distribution. So suppose there are two class, then it divide a boundary of maximum margin. Then this no, the features which are near the boundary, these are called the support vectors. So these are demarcated and segregated by this maximum margin. Then the boundaries are created. In the three dimension, it is seen in the input space. Then after three dimension, it is demarcated. So these two features are separated with this support vectors. So this is the support vector machine, and this is the one of the image of different class. The green is the different class, and this color is the different class. So these are demarcated, segregated by some margin is there. So if the margin is very close, then some of the features are included in the class 1, and other features are also included in class 2. So based on the margin value, the classification, the classes of some of the input of the classes are included or excluded. Then random forest is also a machine learning classifier. It is also in the supervised classification, and it creates some multiple decision tree using different bootstrap sample of training data. So it is at each split is a tree, and select random subset of feature to decide the best split, and classify each pixel using all these trees, and majority vote determine the final class. So suppose there is a agriculture areas, so it created trees and decide that it is not agriculture area, and it is a scrubland area, it is a forestal land area. So if the maximum trees decide that it is a cropland area, then it is finally decide that it is a cropland area. So this is the decision trees. So based on this is classifies. So this is one of the false color composite image. And this is the original image. After classify in different methods of classifications like SBM method or random forest method. So these are the same image is classified in the different manner. So some algorithm classify into different features. So some algorithm create a different feature. So based on the accuracy and algorithm and the user uh, and the user inputs, it creates the different classifications. But in other sense, if the user have a better knowledge, then it create a better and a high accuracy classifications using the manual classifications, but it takes more time. That's why we generally prefer the machine learning technology. Then there is unsupervised classifications. So in the unsupervised classification, there is a two type of classification is there, that is k means and isodata. So this is came in, suppose we think that there is a five categories of the information like water, forest, agriculture, built up land and buried land are there in the satellite image. Then it create the five classes based on our inputs. So this is the process of the k mean. So demonstration of the k mean cluster. Suppose there are suppose in the k mean there is a three class we just decided. So in the satellite image only three classes are there. So the red, green and blue. Suppose red is the forest area, suppose green is the forest area, red is the built up land and blue is the water bodies. So based on this, the blue try to collect the informations that, so suppose blue is a 150 or 1, so blue is 10 to 15 reflectance values. So it collect the data of same reflectance values near to this. Suppose 15 means the reflectance near to 20, 25, it collect and categorize it to their classification as a water bodies. Then green also searching for the same values or near same areas values, then it categorize in that it is a forest area. And same thing, built up land, the built up land generally reflects the more. So it values goes from 200 to 220. So near the 180 to 230 values, it collect all these values and categorize as a built up land. So this is the boundary created in the second image, and after that it create all these categories, and the final fourth image is it categorized into three category. So if you categorize it is into four or five categories, then the boundary is different. So this is the original image of the unsupervised. This is the original image of categories of pixels. Then k means clustering. So it also categorize some of the part of these areas. So this is the error. This is the error based on the original image. So it can sometimes categorize other part of these areas also. So it is an unsupervised classification. Like that's why it create more error as compared to the supervised classification. But when we don't know about anything about some areas or some specific knowledge about the areas, then we apply this unsupervised classification. Then like this k means it is isodata also require number of cluster to fix in advance, and it iterates 3 or 4 times to finalize their classification techniques. So isodata, this is the isodata. So it just iterate. This video shows that how their boundary are created in different ways. So first is initially clusters centers, then assign some pixel to cluster, then recalculate the cluster center, then repeat until the stopping criteria. So the cluster are continuously moving and create some boundaries. based after finalization of this boundary, then create the final boundaries of different classes. So this is about the supervised and unsupervised classification. We just show some unsupervised classification. Suppose in this satellite image there are 9 classes are there. So just go to the ISO cluster unsupervised classification technique. You have to give the input raster band. Then how many classes? So in this second column and second row, there is number of classes. So how many classes are there? So 9 classes are there. After that, just wait for the analysis. I think some issues are there during the operation. I will check later. Okay, so likewise, all this unsupervised classifications are there, and just create the boundary of different classes. So, so these are the features of the supervised and unsupervised classification. So, general the algorithm used for the supervised classification is maximum likelihood, minimum distance, parallelopipe classification, then support vector machines, then k nearest neighbor, then decision tree classifier, random forest classifier, neural network classifier, and Mahalanobis distance classifier, and Bayesian classifiers. So these are the algorithm used for the supervised classification technology. And what is the advantage and disadvantage? So it is high accuracy possible if the user give the better sample data, and it is a user control classes because user have the samples and it give the samples of different classes. Then it is a non output categories and useful for land use mapping, better for heterogeneous region. That means if some areas have the forest, agricultural land, water bodies, croplands, and all different features are there of different area, then supervised classification is best for this. And it is handle mixed pixel with advanced method, and it is effective with ancillary data like previous data, and compatible with GIS integrations, and it is allows repeatabilities and comparison. So we can use, suppose we have given the 5 sample of particular area and it give some of the error and or some mismatch with these features, then we create 10 or 11 samples of different features, then it give the accuracy level is higher. So it is very essential for thematic mapping of some of the time forest classification, also supervised classification technique was also used. And disadvantages is it requires extensive training data. So for more accurate, it needs more training data. Sometimes more training data give the confusion to the machine there, because if give the more training data, then the more pixel reflectance values are given for particular boundary, then the other boundary have the similarity pixel informations, so that may be some of the issues. So it is sometimes give some wrong informations, and it is time consuming because we gave the sample data of different features, so we have to take different areas. Suppose the water bodies or pond and lake and dam or river is different tone, and for this we have to give each one or two sample from different water bodies, otherwise it gives the different uh, boundary estimations. That's why it is very much important for water bodies. We have to calculate all the different boundaries, and it is biased by training data quality. So training data means it is a user sample data or any user uh, land use land cover some water body sample data, unlimited generalization ability, and costly ground survey required, and it is error if training sites poorly selected. So if the training site is wrong, then it gives the wrong information. Suppose we have given the input of water body pixel and given the system that it is a forest land, then it gives the wrong informations. And it is also sometimes affected by atmospheric effect, due to some atmospheric effects. So some of the features look like the other features like the agricultural lands or other features, and difficult in dynamic landscape and misclassification in overlapping signature. So when overlapping signature means when same reflectance are shown in the different features. For suppose in the cropland, if the signature is similar to the settlement areas, then it gives the confusion to the machine learning technology and give some wrong calculation.
Sir, can you please explain the first point you were mentioning regarding pixels and boundary? Similar information you were saying something.
Which one? In this slide?
When you were, yeah, in this slide you were saying something on similar information regarding pixel boundaries in the first point of the when you were starting the disadvantage.
Okay, okay. Similar information means, suppose I just give you one example. Suppose this is the agricultural land. This area is a agricultural land. So this has the reflectance value nearly similar to, suppose, the sand area. So this is the sand area. Suppose this sand area have the same reflectance values near to the dry land of the cropland areas, then it wrongly calculate the classification technology. Because if the same pixels are there, if we give this information, if we create a one polygon and give to the system that this sample is the sand area, then this is also a sand area. This is a wet sand, this pixel information. This is a dry sand. This is some wet areas and the water bodies are near these areas. So this is also a sand. So this pixel information, if it is equal or nearly equal to the this pixel information of this agricultural land areas, then it miscalculate the features. But this is the sometimes we create the we have the some problem. That's why we create some different band based classification. So this is the false color image. We create true color image based classification. So it creates different features and some other band combinational classifications to maximize to minimize the most of the errors. Okay.
Thank you.
So this is related to the advantage and disadvantages, and some application is on urban land use, land cover mapping, forest type classification, in agriculture crop monitoring, urban growth studies, wetland mangrove mapping. So most of the time mangroves are the evergreen forest which looks very brighter tone in the satellite image. So this is the mangrove area. It is the present in the intertidal zone. So this it gives the high reflectance values in the infrared bands. That's why most of the time during the mangrove mapping we use the false color image. So this is the mangrove areas. This is the mudflat area. So generally the mangrove is present in the mudflat area or the intertidal zone. Saline water is needed for this mangrove. And this is the I just show you one thing. So this mangrove, this is the mangrove and this is the Kajuruna forest. That their tone is different. So these are same. And these are the forest areas having the different species. So this is the mangrove forest, and this area, this is a small linear area. This linear area is the Casuarina plantation area. So it clearly demarcated forest areas with the help of this infrared range.
Sir, I have one question. Like you mentioned that uh, different features may have different, we may have similar signatures, spectral signatures. So it may confuse the machine that the classification may get mixed up. But on the other hand, can we also utilize the association? Because if we, like in the example that you gave, that sandy area might have similar reflectance to the dry area in the agriculture plot. But if you consider the association, like sandy area might be surrounded by water, whereas the agriculture area might be surrounded by maybe built up area. So we can use those association information also, right?
Actually, machine learning also use this association technology. Uh, Also, if we give this sandy area samples, then it create the sandy areas. But sometimes small polygons also created in the middle of the areas, that it is different features. So it is not every time it create the error, but it is related to the, suppose sand features is very bright. Suppose this is the cropland areas. So in this cropland areas, some of the crop forest are there, some uh, mm, swampy areas are there. So in the swampy areas and mud flood areas, in the intertidal zone of mud flood area, this is the mud flood area, it is the mold flood area, and some of the swampy areas are there. So in this demarcation, it is very much difficult because swampy area also includes the surrounding the water bodies in the inland areas, and mud flood area also present of the water bodies near to that. So in that time, some of the values are incorrectly and wrongly matched. Otherwise, it is not giving the large area error. But based on the resolution, if the high resolution satellite image is available, then the accuracy is more. So it takes some time for calculation, and if more samples are there, then it give the accurate data. Okay.
Thank you very much.
But manual digitation is very accurate, but it takes time because we know this is the different area and this is the different area. So this is some of the applications, and some of the mostly we use the open source Landsat image, Sentinel image, and some commercial satellite image like Worldview and Cartosat of ISRO, and LIS4, that is 5.8 meter resolution. They are very good accuracy image. So we can create some supervised classification based on this image, and it is give the quite good accuracy. But for larger view and for the basic information, if you need, so what is the forest areas and what is the water bodies, then we can use this sentinel data and other data. Then unsupervised, that is also discussed. So in this, there is an advantage that there is no training data needed. So it directly calculate based on the pixel information and categorize based on the user defined can a number. Suppose we give the 7 categories, then it creates 7 categories. We give the command that create 9 category out of this satellite image, then it create 9 categories. So it may be right or wrong, but just to show how many categories are there present based on the reflectance values. So some of the features may be wrongly mapped, but just when we don't know about the feature, just give the system that I think it has a 9 category. So based on the reflectance, they give the boundary of 9 categories. So it is a simple and quick process, and useful for unexplored areas, and can reveal hidden patterns, save cost of ground survey. So there is no ground survey is needed. But in the supervised classification, if ground based information is there, then it could give the accurate value. And it helps in initial classification and work with large data sets, and suitable for time series analysis Suppose the urban growth model is calculated or urban sprawl, then we use this unsupervised. Then provide natural grouping and good for the exploratory studies. And disadvantage is that it's less accurate than supervised methods because the user has the analysis based on the local areas, so it gives the accurate sample data for this sampling. And cluster may not match the real world classes, and user has less control in the unsupervised, and it produce some mixed classes of some two three classes, and it create a one boundary, and difficult to validate accuracy, and not ideal for the detailed studies. For detailed classifications, it is not ideal. So basically, for low and moderate resolution data, unsupervised classification is not, it's good for them. So for broad land cover classification, the geological mapping, climate biome studies, water body mapping. So in the water body studies, you can give the accurate data because most of the time water bodies have the low reflectance values, so it create a good boundaries. And for the change detection, wetland inventories and all related to large area mapping without field data. And some of the example is applying k-means on Sentinel-2 image and algorithm grouping pixel, then produce broad land cover map for particular areas in very quick time. And this accuracy is between 60 to 70%. Maximum accuracy is 75%. So it is useful for unknown study areas. So this is about some supervised and unsupervised classification technique. We will later give some example of supervised and unsupervised using some satellite data. If it is possible, then we will try in the R programming or any other RJS or other software. Okay, so
Sir,
all
if
good
you
now.
have couple of minutes, yeah, is there the earlier part for first 5 minutes you showed in ArcGIS, ArcMap, how to create STC? Can you please show it again? Because in the first semester we learned in QGIS, so I'm very curious how you did it in ArcMap, what you were showing in Arc, how you created in ArcMap. Can you please show it what you showed?
Okay, okay. So basically, so these are the bands, so individual bands. So when we download a satellite image, so it give the single band informations. So all the tiles
Your
are in the
screen is not
single band.
visible. Your screen is not visible.
Screen not visible.
Not.
Okay, just a second.
Yeah, yeah. Now it is. Yeah, it's
Now it is visible.
Yes, sir.
yes,
Yes.
the black and white image. Yeah, yeah,
So it is black and white image, na?
Yes.
yeah, yeah, yeah.
Okay. So these are the different bands, and all image bands have different reflectance. So it look like different reflectance like in length. So I have some seven bands. So these seven important bands are there of the Landsat 5: band 1, band 2, band 3, band 4, band 5, band 7. So if I want to composite all this uh, in one file, then just go to the Windows, then image analysis, just select all this band, then just click on the composite band.
Com-
So it create automatically the composite band of all this image. Then we have to, so it is a temporarily created this boundary. Then we have to select and export this image into TIFF file or NV or IMG file. So generally we use the TIFF file. So it is 630 MB. So we have to export it like this. Otherwise, if there is a raster tool is there, Spatial management. There is a raster catalog. This is a composite band tool is there. So in this tool, we can create composite bands of giving all these bands. Then it create a output raster. So it is a direct tool is given in this tool to directly quickly create this composite band. And in toolbox, we have to go to the data management tool, then raster, then raster processing and composite bands. So likewise, all the raster analysis are mm, mm, processed with the help of this all this raster tool. So in the ArcGIS, very uh, um, all this large number of tools are there for different applications. So it is a this is like this. So NDVI and any other process are there. So we will process one by one after completing this class. Next class, we will create the NDVI calculation using the ArcGIS. So previously we created NDVI using R. Then we will see how to create NDVI in ArcGIS. Okay.
And sir, you also change this to HPC, or is it right now in two color composition?
No, no, it is so when we open and properties, so these are the five bands. So its name is just band one, band two, but generally all these bands are created. You just check, and the blue
So
is
how
blue.
all are termed as band one here.
No, no, no.
How do
The
you distinguish?
naming is by default is given band one, but it is different band. All these five are different. So this is created. So this is the band five, four, three, two, one. So for
This is
blue,
in which layer, sir? This is in composite layer.
and this
This
is
is
the
in
composite.
composite layer.
Yes,
Okay.
this is
So
composite.
you in the composite layer you change the symbology. How?
Just a second. So these are the band. So for blue, I just give that band 2 means in the false color blue to green. So band 2 is my green. So if I change my different band oppositely, then it create a different color. So that's why for false color blue is given to band 2, green is given to band 3, and red is given to band 4. That means infrared. Band 4 is infrared. So red to infrared, green to red, blue to green. Then it creates the false color image. It is the false color image. So similarly in composite, which and now we create this. Just a second.
In composite, all the bands are band underscore one. So in the earlier one, it was fine, 4, 3, and 2 RGB. But in composite, when all are band one, how do you distinguish?
Actually, it is a we create this temporarily. That's why it create the naming differently. So suppose 7 for red, it is 1, 2, 3, 4,
4,
4.
4, 3, 2.
Green 1, 2,
Third one.
3. Then it is 2. Then it create a false color. Think
I think
7.
for blue, it will be 2. For blue, it will be 4.
Blue is 2.
Okay.
Then it is 3. Then it is 4.
Yeah.
Yeah. It's create the same thing, but the naming is different. It is a temporary. quickly created this image, so the band is not changed.
And this exactly same thing we did in R, right? When we
Yes,
did
yes.
this
Same. So the L5 RGB is created
linear.
by R, this image, and composite is created by RGS. Okay.
So when we did text is equal to linear, what exactly were we doing in R, that command?
Actually, X is equal to linear. There's just stretching the bilinear interpolations and all different uh, accumulation techniques are there. So I think uh, some algorithms are there. That's why it is the coding is like this.
So we cannot do composite in R. Why did we use R then?
No, we can composite in R. I have already shows. I think you are not at that time. So this is the composite image in R. This is the image. So this is the layer stack of all these image. Suppose
Okay,
just
okay,
a
got it.
second.
Okay, same thing we did it in R and same thing we did it in R. R.
Yes, yes, yes. So this is just a second. This is given the four bands B1, B2, B3, B4. This is the layer stacking. So all these bands are there in one CP. There's in CP our object. Then we just RGB to this CP. So R is equal to 4, 3, B and stretch linear. Then it create the RGB band. Okay.
Awesome.
Yes. So same things can be possible in R also.
Great.
Then we
So
can
there will be
export.
different options.
Yes, yes, there will be
Sorry.
different option. It is also you can also create this composite band using Python script also, and some
I mean different options like linear stretch is one option. There are different options apart from linear also.
okay, yes, yes, may be possible, but I am not exploring this. So if possible, then I can give the answer of related to this.
Thanks. So, sir, tomorrow it will be
Yes,
special
same
analysis
time because
modeling class or
tomorrow Rakesh sir is not there, so tomorrow is not my class. So due to his medical issue, I will continue.
so, okay, tomorrow it will be 6:30 your class only, no?
Yes, yes, yes.
Okay, thank you very much.
Okay,
Okay. Good night.
okay. Good
Thank you,
night.
sir. Thank you.
Thank you.
Thank you.
And Bhavna, is any doubt?
No, sir.
Renu,
Yes, sir.
so tell me.
So no doubt.
No doubt.
Yes.
Okay, okay, okay. Then we'll see tomorrow.